Trying to like price like around there. Like, okay, this sold for 40 bucks. I should sell it for 35 or, whatever. $5 cheaper.
I think of collectibles. I think about Andy from 40 Virgin and how he was so sad he had to sell like all those things.
Oh yeah.
I feel him, feel the pain.
Yeah, how's
She
everybody
was
doing
attacking
today?
you.
Everybody doing
I
well?
wasn't attacking you though. Like no judgment. But that's
No,
what I
no,
think about all the collectibles and
I didn't take it that way.
okay. I'm gonna paint these blue pants silver. Like I'm a nerd, I know. I need a hobby.
All right, folks, let's get started. Can y'all all hear me okay?
Yeah, you sound a little far, but for the most part, I can hear you.
All right, good. Let's see. Let's start. Start by working this last exam. About half of y'all got it. About half of y'all need some work. My dog's gonna be whining a little bit. He got attacked by some other dog yesterday, so he's
Oh no.
sad.
Hmm.
He'll be okay though. He just wants a lot of attention now. So, what I want to see on these quizzes and exams is 100s, because those are the easiest to grade, right? Remember, you can always go here in, where's it, Canvas? Go to the syllabus. There's a link there for tutoring. So if you need help, you can always use the tutoring. Let's see. Computer. There we go. Yeah, right here. Tutoring. You can always click this link. There's the hours. So if you need help, utilize that. Also remember, there's lots of apps you can use to help you. What was there's look them up again. What were those? Photomath. Photomath. And there's Fast Math. And there's a few others. Some of them will not just give you the answer, but it'll give you insight and like show you the steps to solve it, so use those. You can probably even type some of these into Google, type solve for X and type the equation. Okay. Of course, you have to show your work, not just an answer to get full credit. So
What were the answers?
we'll get there. We're going to solve it.
Oh, I'm sorry.
I posted the solutions to this on the website already. You can always go to files.
No, that's my bad. I misread it as the answer was 6 instead of equals 6.
Okay. Yeah, here's the solutions to all the exams and quizzes. I put them up right after I grade them. So I'm going to work them in class as well. So for number 1 here, we need this X by itself. It's being divided by 4. So we're going to multiply both sides by 4. But the X is also being multiplied by 3. So we're going to divide both sides by 3. 3 over 3 is just 1. 4 over 4 is just 1. We have X is 6 times 4. It's 24 over 3. And 24 divided by 3 is 8. That's how you do the first one. The second one here, a lot of people are still making the mistake of only flipping one side. And the variables on the bottom, right, you have to flip both sides. So you have 4x over 3. You have to flip the 6. It is now 1/6. Remember, 6 is the same as 6 over 1. Okay? You have to maintain equality. I had a lot of you, at least a quarter of y'all, are still only flipping one side. You can't do that. If you have 2 equals 2, right? 2 over 1 is 2 over 1. I can't just say, okay, flip one side and say 1/2 equals 2. You know, that doesn't work. Now, the whole point of these equations is you're finding the number that you can plug in to the x so that these are both equal. Let's go back to number 1 real quick before we move on. When you get an answer, don't just be like, I don't know if that's right or not. All right. Here was the original equation.
Plug it in.
We got 8. To see if that's correct, plug the 8 in. Plug that in for x. If you plug that in for x, you got 3 times 8 over 4, which is, see, 8 times 3 is 24 over 4. 24 over 4 is 6, the other side of the equation. So the left-hand side equals the right-hand side. That's what this whole solve for x means, is find the number that you plug in where the left-hand side equals the right-hand side. So this equation down here, we need to find the number that makes the left-hand side equal to the right-hand side. To do that, we rewrite the equation like this. It's an equivalent equation. So the same number for x here works for the same number of x here. It's the same statement, just written differently. Okay. So once we get it like that, we can, basically we've now turned this into a problem like number 1. See, x is being divided by 3. So we have to multiply both sides by 3. X is being multiplied by 4. So we need to divide both sides by 4. Okay. The 4 over 4 is 1. 3 over 3 is 1. And we have x equals 3 times 1 is 3. Over 6 times 4 is 24. 24 is 8 times 3. 3's cancel, you get 1/8. Okay. So we can check our work. The left-hand side of the equation is 3 over 4x. If we plug 1/8 in, 4 times 1/8, we got 3 over 4 over 8, or 3 over 1/2. Dividing by a fraction is the same as multiplying by its reciprocal. So instead of dividing by the 1 over 2, you multiply by a 2 over 1, and you get 6. And that is the right-hand side of the equation. So that's how you verify your answer, you know. Always check your work. Make sure it's correct. You know, don't just get a number and be like, I don't know, maybe, and then move on, you know. Just keep working it until you get the right answer. Any questions about this exam? Nope. All right, let's do a quiz here. Quiz number 1. I mean, not number 1. This is quiz number 3. There we go. Number 1. Solve for x. Let's do 2 over 3x equals 7. And for number 2, find 18% of 92. You can use your calculator for that. All right, so by looking at y'all's exams, about half of y'all are getting them all right, and about half of y'all are making different kinds of mistakes. It's basically 2 mistakes y'all make. When you flip these over, you only flipped one side. The other mistake you made was you'd only multiply one side. by a number instead of both sides. So like up here, like this one, you might have only multiplied this side by 4/3 and didn't multiply the other side. Those are the two basic mistakes. So I'm gonna put you all in the breakout rooms. I'll be sure y'all help one another out. Okay. I'll give you all 15 minutes, so 3:25. We'll come back and then we'll work this problem. So there's no reason not to get the quizzes right. One, because you get to work together and then we work it out in class. You have until midnight to upload your answers, okay? So you could always use the tutoring, and you can always go to the lecture notes, right? I post, here's the lecture notes. At the end of class, there will be a lecture number 3, and in it will be the quiz completely worked out. So the answers are already right there for you. So there's no reason not to get 100s on all the quizzes, even if you make it to class or show up late or anything, you know? So there's your quiz. Let's get you into some breakout rooms here. Find the button. Breakout rooms. Put you into 2 groups. And yeah, at 3:25, we'll come back.
Okay, sir, is it okay if I like walk through this job like with you?
Yeah,
Okay. I don't know if I should wait until like everyone's in here or if everyone is in here.
Do another 20 seconds here. So everybody.
Because they use that photo math and I got a different answer from how I wrote it out.
Okay,
So I'm like conflicted.
well, let's check it out. Let's see, number one here. We got the X on the bottom, right?
Right.
So we need to do the old flipperooski. So we're gonna have,
So you would add 3/2.
and the 7 becomes a 1/7, right? Flip both sides. Okay, we got lightning. My dog's up my butt. Okay, puppy. Is it raining where y'all are at? Thundering?
Yeah.
Not yet.
Oh, yeah.
I just started.
Okay, so when you flip them,
Yeah, we flip
I
both.
thought you would add the 3/2 to the 7 side as well, wouldn't you?
Well, one step at a time. First, flip both sides. So that's what we did here. We got the 3x over 2 instead of a 2 over 3x,
Mhm.
1 over 7 instead of 7. So now we have to get the x by itself, right? Now that we got it on
Right.
the top, it's being divided by 2. So let's multiply both sides by 2. And it's being multiplied by 3. So let's divide both sides by 3.
It cancels out.
So the 3's go
Okay.
away, the 2's go away. And we just have the x. 2 times 1 is 2. 7 times 3 is 21.
Okay.
Does that make sense?
Why in the past have we like added like is it because of the X's at the bottom? Is that why we have to get the X on top?
Yeah, because it's on the bottom, we don't want it on the bottom. So that's why we do the flip. We flip both.
Okay,
Okay.
that makes sense.
Yeah. And now once you get it on the top, it's like all the other problems.
In my mind, I was like, it doesn't matter where X is because it's gonna be the only thing left. Like,
Here, let's
but okay, that makes sense.
before we go on to number 2, I'm gonna put number 2 on the next page here. Let's check our work.
Look it up.
All right, yeah. So what this is asking is what number can you plug in for x where both sides are equal? So the left-hand side is 2 over 3x. If we plug in 2 over 21, 2 over 21, we get, let's see, 2 over 3 times 2 is 6 over 21. Now, instead of dividing by 6 over 21, that's the same as multiplying by 21 over 6. So that gives us 42 over 6, right? And 42 is 7 times 6. The 6 go away and we get 7. And that is the right-hand side.
Mhm.
So that's how we know we did it right, by plugging it in, making sure the left-hand side equals the right-hand side. Okay. This sentence right here, 2 over 3x equals 7, is logically equivalent to saying x equals 2 over 21. All we're doing is we're taking this sentence and we're rewriting it, and then we're rewriting it and rewriting it to where its point is clear. X is 2 over 21. Any questions about number 1? All right. Let's check out number 2 here. To find 18% of 92, we take our 92 and we multiply it by 0.18, which is 18%. And we check our handy calculator. 92 times a 0.18, and we get 16.56. And that's it for that one.
See, I was confused about that one because the other day we were writing them as like x equal equations. So I was trying to like write down an equation for it instead of doing it that way.
Okay, if you wanted to do it like that, what we would do, this over here, we'd say 92 times 0.18 equals x. That would be the equation. It just so happens that x is already by itself. So we could say, okay, well then x is just that. Does that make sense?
Yeah, I just wrote it the wrong way first. But then I changed it to 18 over 100 equals x over 92. Would that, I got the same answer, but
Okay. Yeah, it works out then.
I think you're just overthinking it because it's so simple and everything else we've done
I know.
always difficult.
Yeah.
Yeah. I overthink a lot of things. So.
You're not the only one.
It's not a bad thing in math class. Just remember, math is just like anything else, you know? All right, let's see. What was I saying? Somebody told me when I was cleaning the hotel rooms to check the Bibles for money. So I did, and I found $1 in the Mormon Bible. But I didn't get to keep it because they had written on it, pass it on.
Oh,
It's on to you. It's yours now.
Well, you probably are passing it if you use it to buy something.
Oh yeah, good point.
logic,
Yeah.
logic.
All right, let's see. This is where we're picking up. We left off on number 10. Dang, where's that? So I think we're here in proportions. Joe's heart beats 11 times in 10 seconds. At that rate, how many times does his heart beat in 60 seconds?
66.
Right, well, 11 times in 10 seconds, 60 seconds, you just multiply 11 times 6, right? 66 times. But let's set up the equations first. Let's do this using the proportions. We have 11 times in 10 seconds. How many times does it happen in 60 seconds? So that's the setup. So we just need to solve for x. So to do that, since we're dividing x by 60 seconds, let's multiply both sides by 60 seconds. Okay. Seconds go away. What happened to my equals here? Sorry about that. Equals this equals this. There you go. So divide by 60 seconds. So we have our x here by itself. 60 times 11 over 10.
660.
Yeah. 6 times 11 is 66 times, just like we thought. Let's check another one here. One bagel has 320 calories. How many calories are in 2.5 bagels? Well, this one's easy, right? If every bagel has 320 calories, we just multiply 2.5 times 320. So let's set this up with proportions. One bagel has 320 calories compared to 2.5 bagels to x calories. And then we solve for x. So since the x is on the bottom, let's flip both sides and switch both sides. Because I like to have the x on the left. Let's put x over 2.5. And then 320 over 1 bagel. You'll see what I did? I did the whole switcheroo like this, right? But then I also did the switcheroo like that, just so that X would be on the left. All right, so now we need to solve for X. So since X is being divided by 2.5 bagels, we need to multiply both sides by 2.5 bagels. So the 2.5 bagels go away, and we have X. Bagels go away, and all we're doing is taking 2.5 and multiplying it by the number of calories in a bagel. So 2.5 is 2.5 times 320. We're left with units of calories. So what is this? 320.
800.
800 calories. Any questions? All right, a leaking pipe can lose 24.7 gallons of water in a week. How many gallons are lost in 30 days? Well, here we need to like work in the same units. We're talking weeks and days. So we can either convert 30 days to weeks and have ugly decimals, or we can convert week to 7 days and not deal with decimals. So I say a week is 7 days. All right. So if we have 24.7 gallons is lost every 7 days, how many gallons are lost in 30 days? That's our setup. So to solve it, let's multiply both sides by 30 days. So that way I have my X by itself. Days goes away, we got 30 times 24.7 over 7 gallons is the units we want. And does anybody know what that is?
105.857.
105.857.
I think so.
Now, let's see. So, yeah. Keeps going, but that's good to 3
I
decimals.
just gave you, yeah, I just gave you the first 3 decimal points.
Now, here's what we'll do. We'll do a squiggly equal. So it's approximately equal. It's not exactly equal. It's just really close. So I'm going to put approximately equal to that. That way they know that it's been rounded.
Would you accept that answer though?
Yeah.
Okay.
Would you accept if we rounded it up to 0.86?
Yep. You know, if you put that squiggly there, then I know you're rounding. See what I mean? If you put it just a straight old equals, it's not exactly equal, right? I'd still give you credit, but if you want to do it right, you want to say exactly what you mean. You want to be precise and concise at the same time.
Well, the reason I asked is because we don't have the squiggly equals on the computer. So if we just put equals, I mean, is an acceptable answer.
Okay. Well, there should be a squiggly equals. I just forget how to make it. It depends on your system or whatever.
I have a single squiggly line, but I don't see a double.
Ah, okay. All right. Well, yeah, if you're typing it, just use what you got. raining hard here. My doors leak sometimes, so I have to make sure I don't have water running in my house.
Do you have those weather strips on the side?
I do, but when the wind blows the wrong direction, somehow it just comes rushing in above my doors, both sides of my house.
Bottom or sides?
The top and the sides, actually.
Huh.
I put some flashing in above the doors, and that's helped a lot. But no, I still get it to the sides sometimes.
Do you
Might
live out
need
in
a-
Bandera?
What's that?
Do you live out in Bandera?
Yeah, I live out in Pipe Creek by Medina Lake.
My door used to do that until I put weather strips to make it sure it's sealed properly.
Yeah, I put those in, but my dog ate half of one of them out, so I gotta replace it.
You're about to be through the rain here in a little bit.
Yeah, it's raining here pretty hard. The other day I came home from the hotel in Bernie and it was raining so hard, it was flooding everywhere all the way home. And then I got within like 300 yards from my house and the rain just stopped and it was just bone dry. There's just like dust in the air, trucks driving and you know, the dirt just bone dry. It hadn't been a single drop all day and it stayed like that all day and all night until the next day. Weird. All right, let's check out these percents here. We'll probably use one of these equations here. Some of this stuff we should be able to do without the equations, you know. Should be kind of common sense. So if you take your price and then find out how much tax there is, you get your total, right? To find out how much tax, you have to take your price and multiply it by the tax rate. So what we're looking at here is price plus price times rate gives you your total, right? But this you can factor. You can write this as P times 1 plus R, right? P times 1 is P, oh, I'm sorry, I need a plus here. That looks a little better, right? The price plus the taxes. So since they both have a P, you can factor the P out. So P times 1 is P. P times R is PR. That gives you your total. This equation here is trying to tell you your percent increase or decrease. All you do is look at the difference in the price change, how much the price has changed, and then put that over the old price. And that gives you the percent increase or decrease. All right. So let's look at 14. Amy bought a pool hall for $219,765. That included the 5% tax. What was the price of the pool hall before tax? So we want to know what the original price was, right? P equals what? Well, we know if you take the price and get the taxes at 5%, right? This is your taxes on it. So if you take the price and add the taxes, they say you get this much. So y'all follow the setup there?
Yes.
That's just the taxes. But we need to find out what P is. So I'm going to take this guy and I'm going to factor it because we have two P's. We need one P. So I'm going to rewrite it like this. 1.05. Okay. P times 1 is P. P times 0.05 is P times 0.05. Y'all follow that?
Yes.
Okay. So now what we can do is we have P 1 plus 0.05. 1.05. So factored out a P, put these two numbers together. Now since P is being multiplied by 1.05, I need to divide both sides by a 1.05. And my calculator, 219,765 divided by 1.05 equals $209,300. Let's check our work. So if that's the price, and then we add our taxes, which is 5%. Let's see what we get. We get 209,300. Our taxes here, when I multiply those, we have $10,465 in taxes. So when I add these, I get 219,765. So it's good. Any questions? All right, let's move on. Let's talk about Steve here. Actually, let's put that on a new page. Steve needs to buy his sister a birthday gift from the mall. He sees a shirt that is normally priced at $24.50, but it's on sale for 20% off. If the sales tax is 8.25%, how much is he going to pay for the shirt? Well, there's two ways of doing this. We could say, well, let's find out the discount. So we multiply by a 0.2.
4.9.
4.9. That's the discount. So instead of paying that, we'd have take 4.9 off the regular price, right? So 24.50 minus 4.9. 1960 is the new price. Then now we add tax. So we have 1960 times a 0.0825, right?
1.617.
So that's our tax. So the total is 1960 plus the dollar in tax.
21.217.
1.217 or $21.22. Forgot my dollar sign. That's one approach. The other one is, instead of saying, oh, it's 20% off and finding 20%, we could say, well, you're paying for 80% of it. So, or you could approach it like this. Price is that times 0.8, because if it's 20% off, you're only paying 80%. Of course, you're going to get the same answer, 1960. So you could approach it either way. And then you follow through like we did up here. Any questions about that one? All right. Let's see what's up with Thomas here. Thomas is selling his Honda on consignment by leaving it with a dealer. The dealer is going to get 25% of the selling price. So how much must he sell this car for if Thomas is going to get $14.75? All right, so we're saying we got some price. You can call it PX, whatever you want. And let's see. The dealer gets 25%, right? So that means Thomas is getting 75%, right? So we take this price and we take 75% of it. We want to get at least $14.75, right? So if the dealer gets 25%, Thomas gets 75%. So 75% of the price, he wants it to be $14.75. So now we solve for P by dividing both sides by 0.75, and we get 75 divided by 1,966 point, I'm going to round up here, 67. So let's check our work. If we have this price, all right, and we're only getting 75% of it, we indeed will get our $14.75. Questions? All right, in 2004, Javier bought a new television set for 2,500 bucks. And in 2012, he purchased a similar model for 950. What was the percent decrease? Well, let's see. It went from 2,500 to 950, right? That's the change. So what is that? 1,550, is that right?
Yes.
All right, so that's the difference. So to find the percent decrease, we'd say, okay, 1,550 compared to the original price. 1,550 divided by 2,500 equals 0.62 or 62%. Okay. So their formula here and it's a the price decreased, right? So this is decrease. Or we could just use the formula. New minus old over old times 100. I did old minus new. Let's see, the new is 950. The old is 2,500. put that over the old. That's what we did right here. The difference between the new and the old. We did it backwards. When you write it like this, you get the same number. You're going to get 0.62, but it's going to be negative. Oh, actually, hold on. They actually throw the 100 in there. So what they're getting is negative 0.62 times 100, or negative 62%. See, the negative means decrease. All right, up here I just did them backwards and just wrote the word decrease. So you can tell if it's negative, that's a percent decrease. If it's positive, that's a percent increase. Does this make sense? Find the difference, divide by the old price. That gives you your percent decrease or increase. All right, the price of gas increased from $3.25 per gallon to $4.05 per gallon. What was the percent change to the nearest percent? Okay, well, let's see. 405, 325, was that 70? That's 80 cents. So it changed 80 cents, right? And it was an increase. So we take our 80 cents compared to the old price. The old price is $3.25. And that gives us 0.8 divided by 325. That's 0.246. It's approximately, I'm rounding it. So this is 24.6%. They want it rounded the nearest percent. So we round this up to 25%. Any questions? Okay. We're going to move on to mixtures now. Let's see, it's 4 o'clock. Let's take a 15-minute break. And then we'll knock out mixtures. So we'll come back at 4:15 with our minds fresh and ready. All right.
Sounds good.
All right, class, y'all back with me?
Yep.
All right. Let's check out the mixtures here.
Here.
Leave some room up here. So mixtures. When I first started teaching this class, I looked at this section and I had a lot of difficulty trying to figure it out. And then I finally figured out there's an equation missing that they don't give you, a formula. I'll give that to y'all in a second. Let's look at this first question here. If you have 1 gallon of 100% apple juice, and you mix that with 1 gallon of water, how much total liquid results and what percent is juice? Well, if we're mixing a gallon with a gallon, we get 2 gallons. And since the first gallon was 100% juice and the other was just water, also known as 0% juice, the result would be 50% juice, right? Get 2 gallons of 50%. That's easy enough. But think about what if they changed these numbers? What if it was like 3 gallons of 60% juice and a half a gallon of 20% juice? That's a much more difficult problem, right? So this next one, what if you mix 3 gallons of juice with 1 gallon of water? That's a little more difficult. We can still do that one in our head though. If you have 3 gallons of juice and a gallon of water, you end up with 4 total gallons. 3 gallons are juice, so that's 75% juice, right? 3 out of the 4 gallons is juice, 75%. So we can do that one without any formulas. But what we want to think about is there's 6 variables here. There's the volume, I'm going to call it V1, volume of first liquid, or I'm going to call it liquid number 1. So this 1 here, that's a subscript. There's also V2. That's the volume of the second liquid, right? And there's a third volume, volume of liquid number 3. This is the resulting mixture, right? So there's 3 volumes. So we have 3 different variables there. We also have C1, concentration of, ran out of room, liquid number 1, right? We have C2, hell, C2, the concentration of liquid number 2, and we have C3, the concentration of liquid number 3, again, of the mixture. Y'all see that? There's 6 variables. So let's do this first question. Even though it was really easy, we could do it in our heads. Let's see how this would work out. Oh, we need the equation here though, right? Our formula. Here's the formula that you're going to need for mixtures. You take the first volume, multiply it by its concentration, and you add to that the second volume times its concentration. You get the third volume at its concentration. So that's the big formula that you need to do all these mixture problems. And it should kind of make sense, right? You have a volume at its percent concentration, another volume at its percent concentration. You're mixing them together to get a third volume at a third concentration. The other formula we need is real easy. The first volume added to the second volume gives you the third volume. Do those 2 formulas make kind of sense to you? This B looks like an R, V. All right, those are critical. So let's look at this first question. We're mixing 1 gallon. So V1 is 1 gallon. And it's at 100% juice. So C1 is 100%. We're mixing that with a gallon of water. So V2 is also 1 gallon. And since it's water, the second concentration is 0% juice. Water has no juice in it. How much total liquid results? So they're saying, what is your third volume and what percent is juice? So what is the resulting concentration? So they gave us 4 numbers and we have to find out the other 2. Well, the volume is easy, right? Since V1 plus V2 equals V3, V1 is 1, V2 is 1. We end up with 2 gallons for our V3, right? What about the resulting concentration? Well, let's plug what we know into this formula. We have 1 gallon at 100% juice. We have 1 gallon at 0% juice. And we end up with 2 gallons at its concentration. So now we just solve for the concentration. 1 times 0 is 0. So we're left with 1 times 100%, that's 100%, equals 2 C3. So to get C3 by itself, we divide both sides by 2. So C3 is 100% divided by 2, or 50%. Exactly what we thought it would be. Let's look at this second question and use our formula. We eyeballed it. This one where 3 gallons juice, 1 gallon of water. We in our heads we figured out it's 75%. Well, let's see. We're mixing 3 gallons. So V1 is 3 gallons, and it's of juice. It doesn't say what percentage, so we're going to assume that it's 100% juice. And they're mixing that with 1 gallon of water. So our second volume is 1 gallon. And since it's water, that's 0% juice. All right, so again, they gave us 4. We can find V3. We just add our 2 volumes together. It's 3 plus 1 is 4. So what's our fancy equation? V1C1, we're mixing that with the second volume at its concentration. We're getting the third volume at its concentration.
Are you writing on the screen?
Yeah, y'all not being able to see that?
Okay, it just popped up right now.
Okay. There's just a lag, huh? Let's see. Did my Zoom dump on us here? Guess we'll just give it a second. Maybe it'll catch up. It seems to be lagging a lot. All right. Let's see. The first volume is 3, and it's at 100%. Can y'all see that writing? And then 1 gallon at 0% gives us 4 gallons at its concentration. All right, can y'all hear me and see what I'm writing still?
Yes, sir.
The rest of the equation is not there.
Yeah, we can see your cursor, but the last thing it says is 100% plus.
Okay. So it's just lagging really bad. What am I gonna do here?
In class and give us all 100.
Right?
Ah,
Let's see.
good.
We're trying to help us all, guys.
Let me try stopping the share and then restarting it.
I think you got to do it for the team.
Yeah.
Yeah, Zoom seems to be frozen on my side. Yeah, I'm gonna have to force quit Zoom and restart, which means we're gonna lose the video. We'll only get the second half, but
You can see your cursor just fine, just nothing that you write.
yeah, that's not gonna work. Let's see, what can I do here? Yeah, give me a second. I'm gonna have to end Zoom and then relaunch. Let's see, it's what, 4:26. Let's try to get back on at 4:36. I think I should be able to get it done by then. So I'm gonna force quit Zoom. All right, can y'all hear me?
Yep.
Yeah.
Yes.
All right.
Yes.
So then it's just force fit part of the screen sharing part of Zoom. Let's see. Try to share again. Okay. All right. Can y'all see me scribbling?
Yeah.
Yes. Yay.
Yeah, I can see you now.
All right. So let's start over on this one. Okay. I guess it's still recording. We didn't lose the recording. That's good. Remember that.
Interesting. I'll be right back. Start with the restroom.
Okay, so we're working on this second question. If we mix 3 gallons, volume 1 is 3 gallons, and it's 3 gallons of juice, so concentration 100% juice. We're mixing that with 1 gallon of water, so our second volume is 1 gallon, and it's water, so its concentration is 0% juice. So we know these 4 numbers. We can find our third volume by adding the first 2. Got 3 plus 1 is 4 gallons. That's in volume 3. What we don't know is the third concentration of the mixture. We know that B1C1 plus B2C2 is B3C3. So if we plug in our numbers here, we know we have 3 gallons at 100%. We're adding that to 1 gallon, that's 0% juice. We're ending up with 4 gallons at some unknown concentration. So now we can solve for our C sub 3. So 1 times 0 is just 0. 3 times 100, 300%. Is 4 times our third concentration. So we just divide both sides by 4. So C3, 300 divided by 4 is 75%, just like we thought it would be. All right, does that make sense? Kinda. There's big formula, 6 variables, but these get easier as we go on. Let's look at another one.
Okay, it's not that hard.
Oh, it's nice to hear. All right. If we got 2 cups of water, our first volume is 2 cups, and it's water. So the first concentration is 0%. And it's from Great Salt Lake. Oh, wait. 2 cups of water from the Great Salt Lake of 10% salinity. So our first 2 cups here have 10% salinity. So we're talking about salt. And we're mixing it with 2 cups. So second volume is 2. And it's of swimming pool water, which has 0% salinity. So the concentration of our second solution is 0%. How many cups result? So that's our third volume. And what is the salinity of the mixture? We want us to first estimate a reasonable percentage range before we try to solve it. Let's see, 2 cups at 10%, 2 cups at 0%. So that gives us 4 cups. Half of it only had 10%, right?
Mm-hmm.
So if half of it had 100%, we'd be at 50%, right? If we had 2 cups at 100%, 2 cups at 0, we'd end up with 4 cups at 50%. But 10% is 10 times less than 100%. So instead of end up with 50, I'm guessing we divide that by 10, we get like 5%, something like that. All right. We got 0% and a 10% mixed together. So we have to end up with something less than 10%, right? Right. If we had our second volume, if they were both 10%, we'd end up with a 10% solution. But since one of them doesn't have any salt and we're mixing it with one that has this much, it's got to be less than 10%. So let's see what we can do here. We don't know our third volume, but we can easily find it. Because we just add those two together. We have 2 plus 2 is 4 cups. Sometimes they don't give you V1 and V2 to find V3. Sometimes they might give you V1 and V3 and you have to find V2. Just keep that in mind. Okay, so we have our slick equation, V1C1, V2C2, V3C3. So we plug in our numbers. We got 2 cups at 10%, 2 cups at 0%, gives us 4 cups at an unknown percent. That's again 0. So we now have 2 times 10 is 20%, 4C3. So let's divide both sides by 4 to get C3 by itself. 20 divided by 4 is 5%. Right? Pretty slick, right? Any questions about number 20 here? All right. Let's look at 21. All right, if we pour 3/4 of a cup, so V1 is, I'm going to use a decimal here. 3/4 of a cup is 0.75, right? 0.75 cups. And it's of creamer, it's 12% fat. So we're talking about fat here. So the first concentration is 12%. We're adding that to 2.5 cups. So I'll put 2.5 here for the second volume. And it's cups of coffee. So coffee doesn't have any fat in it, right? So the second volume concentration is 0% fat. It's just coffee. How many cups result? And what is the percent fat? So we're going to do the same trick here. We can find our V3. We just add V1 and V2. Oh, wait, we have to do our estimation first. Okay, let's see. 3/4 cup of creamer.
It's 0.75.
But we're adding it to 2.5 cups of coffee. So we have a whole lot more coffee than we do of creamer. And the coffee has no fat in it. So we're adding 12%. We're going to have far less than 12%, right?
The third one.
Because there's a lot more coffee than creamer. So let's just go with far less than 12%. All right, our V3 is 3/4 of a cup plus 2.5 gives us 3.25 cups. V1C1, V2C2 is V3C3. So if we plug in our numbers here, we have 3/4 of a cup at 12% fat. And we have 2.5 cups at 0% fat. Gives us 3.25 cups at an unknown concentration. But this one again is 0. So let me use my calculator. Let's see here. 0.75 times 12 9. Divide both sides by 3.25 to get that C3 by itself. 9 divided by 3.25 is 2.7, and I'm gonna round, so I'm gonna go squiggly to a second. 2.77%, which is a lot less than 12, like we thought it would. Any questions about this one? All right, let's check out another then. All right, we have 20 pints. V1 is 20 pints, and it's at 2% saline. It's mixed with 15 pints at 9%. How many pints are in the final mixture? What is the percent saline in the final mixture? Now let's try to do an estimation here first. So 20 pints and 15 pints mixed together. That's almost equal amounts, right? Close. But one of them has a lot less saline than the other. So some has 2%, and the other has 9%. So let's say we had the same number of pints. If we mix them together, we should end up with a percent that was exactly in between these two. Directly in between 2 and 9%. So right in the middle of 2 and 9%, it's a difference of 7%. After that is 3.5. But right in the middle would be a 5.5% solution. That's if we had the same number of pints here. But we have more 2% than we have of the 9%. So the result should be closer to 2% than 9%. So it's going to be 2% and 5.5%. 5.5 is right in between the two, but we know it's closer to 2 than the 9. I'm gonna guess, I don't know, 0.9% or something like that. All right, let's see what we can do here. We know V3, V1 plus V2 is 20 plus 15 is 35 pints. And we know V1 C1 plus V2 C2 is V3 C3. So we know we have 20 pints and 15 pints at 9%. Gives us 35 pints at unknown concentration. So what do we get? 20 times 2 is 40. That's 9 times 15. Let's see. 9. 135. Add 40 plus 135%. 15 times 35 times C3. So 40 plus 135 is 175. Divide both sides by 35. That is 175. Right, 35. 5%. Yeah. So our estimate was right. We're closer to 2% than to 9%. Is getting any easier?
Very much. I'm waiting for the hard stuff now. I know it's coming. I know there's a trick.
No, it doesn't get much harder than this. All right, let's look at this. All right, we have 2 liters of 3% milk. It's mixed with some 1% milk. It's mixed with some, but it doesn't tell us how much. But we know it's at 1%. So we don't know volume 2. If there are 7 liters of the mixture, that means they're telling us how much we end up with. 7 liters. How many liters of 1% low-fat milk were there? This one. What's our second volume is what they're asking. And then what is the percentage of fat in this 7 liters? So what is our resulting concentration? So this time, instead of adding V1 and V2 to get V3,
You have to subtract V3 from V1.
yeah, exactly. We know this, right? So we know that V2 is V3 minus V1. So we just move that around. So we got 7 minus 2 is 5. 5 liters. So that's our V2. So now we got V1 C1, V2 C2 equals V3 C3. So V1 is 2 liters at 3%. We found out that V2 was 5 liters at 1%. And we end up with 7 liters at an unknown concentration. 2 times 3 is 6. 5 times 1 is 5. 6 plus 5 is 11. Divide both sides by 7. Oops. C3 is 11 over 7%, which is 1 point, so I'm going to round, 1.57%. Okay. Notice every time they're giving us like 2 out of 3 concentrations, you know, the thing is there's 6 variables here. There's 6 of them. They could give us any 4, right? They might give us V2, C2, and V3 and C3. All right. And we could find out the volume and the concentration for the first liquid. Right? If we know V2 and V3, we use this guy to get V1. So once we know that, we just plug in the numbers that we have and we could solve for C1. All right. So all of these so far, we're solving for C3. But we could, if they gave us C3 and didn't tell us one of the other concentrations, we could always solve for the other concentrations. Okay. You just have to give us 4 out of the 6 variables. And since we have 2 equations, we can solve for the other 2 variables. Do another one here. All right, let's so these are mixed practice. All right, so there's 425 stat students at NBC. 35% are going to be nurses. If all the students who plan to attend nursing school are enrolled in stats, what percent of the 15,435 plans to attend nursing school? Well, let's see. All nursing students are in statistics. So if they're in nursing, they are in statistics. But 35% of all the statistics students plan to attend nursing school. So this whole long thing here, we're saying we have 425 stats students and 35% are going to nursing school, and there are no nursing students that aren't in statistics. We know there is 148.75 nursing students. So what percent of all of them plan to attend nursing school? Well, we have 148.75 out of 15,435. And that gives us 0.00964. And I'm rounding here. So as a percentage, that would be 0.964%. So less than 1%. Kind of makes sense. This is approximately 150, right? What would be 1% of 15,435? 1% would be 154 students. Since this is less than 154, we're looking at slightly less than 1%. Does that make any sense? These percentage ones can get tough. I mean, that's a whole paragraph to read, you know? You just have to really sit there and think about it. Check out this one. All right, a pre-election survey showed that 5 out of every 13 registered voters would vote in an election. At this rate, how many people would be expected to vote in a town of 5,850 registered voters? Well, we could do proportions here. Let's see, we have 5 votes out of 13 registered voters. So how many would vote out of 5,850 registered voters? So that's our setup with our proportions. Actual voters to registered voters, actual voters to registered voters. So now we need to solve for X. So we multiply both sides by 5,850 registered voters. So that goes away. We're left with X here. Registered voters goes away. So we have 5,850 times 5 over 13. 5850 times 5 divided by 13 equals 2,250. So that's one way to do it with proportions. Another way to do it would be with percentages, right? We're saying, or use percentages. If 5 out of 13 voters actually vote, 5 out of 13, 5 divided by 13 is 0.3846, or 38.46% actually vote, right? Make some room. So if that's the percent that are actually voting, then all we have to do is take our total registered voters and multiply it by the percent that vote, right? So 5,850 times 0.3846, that gives us 2,249.91. But we're comparing that to, we got a different answer last time, right? We're off by a little bit. And the reason is because right here, 5/13 is not equal to that. It's approximately equal. So when we rounded, we lost exactness. So if you do it this way, we want to get the right percentage, right? Instead of using this decimal, right, the percentage that is voting is 5/13. So instead of writing it as a decimal, go ahead and keep that fraction. Then now it's exact. You see, what did we do up here? It's exactly the same thing we're doing down here. We just used the fraction instead of converting this to a decimal, approximating. Okay, so you can use percentages and you get the same answer, or you can use proportions. Just when you do the percentages, use the fraction instead of the decimal. Okay. Does that make sense to everybody? Kinda? No.
Let's go.
Let's do one more here. This one's kind of neat. This is a neat trick. All right, to estimate the number of trout in Big Bear Lake, they got a sample of 28 trout, captured them, and tagged them. So they grabbed 48 fish and put tags on them, throw them back in. Then later they captured 300 trout, but only 9 of them were tagged. So how many trout are in the entire lake? Well, let's look at this first sentence. We caught 48 and tagged them. There's 48 of them tagged out of the whole population. So 48 out of all of them are tagged. And we're comparing that to 9 tagged out of 300. All right, so 48 out of all of them compared to 9 out of 300. That's our proportion here. So to solve it, let's go ahead and flip both sides so we can have our P on the top. We got to flip both sides. And now we multiply both sides by the 48 tagged. So our population here is 300 times 48 divided by 9. That tag goes away. 300 times 48. 300 times 48 divided by 9 is 1,600 trout. All right, that's a way they often find populations of animals in the wild. But you can use the same trick for all kinds of stuff. Okay. All right, we're down to the end. Let me give you your exam. I'm going to give you the same one I gave to the last class. Let's see. Let's open Sesame. Select copy page. So here's your exam 3. You have till midnight. Don't forget about your tutoring and your phone apps. And don't forget to check your work. I want to see hundreds on everything from y'all, all right? And if you can't get it in by midnight, you can always get it in later, but you'll only get 50% credit because I usually get the solutions that are already posted, you know? If I haven't posted solutions yet, and even if it's tomorrow, I'll still give you full credit. It's usually once I grade it and post solutions. After that, I consider your submissions late and I'll only give you 50%. Again, because the solutions are there. So nobody should ever get less than a 50, you know? Because again, if you don't do it, you can always get a 50 simply by looking at the solutions and putting your answers. So I will see y'all Wednesday. And I'll be here a few more minutes if you have any questions for me or anything.
Y'all have a good day. See y'all Wednesday.
Have a good one, sir. Bye, everybody.
Bye.